One of the critical aspects that's sort of missing here in this particular image is the fact that we're in the most densely populated country on Earth. 150 million people live in Bangladesh, which is about half of the population of the United States living in the area of Iowa and sustaining its own food production. So it's an incredibly rich, fertile environment.
I'm originally from the Gulf Coast and was really fascinated with studying deltas, because in Louisiana you're on a delta that there's flooding that happens constantly. I was there when Katrina happened, so we got to feel the negative impacts of a giant hurricane affecting an area where a lot of people live. That kind of drove a bit of my studies of being interested in looking at deltas as a whole and river systems. So coming here to Bangladesh was kind of a great transition. It was an excellent opportunity to see one of the biggest deltas in the world. In terms of, we've got an enormous population that lives here. There's giant rivers, the Ganges and the Brahmaputra, that discharge into the Bay of Bengal here. And they bring sediment that's coming from the largest mountains in the world, the Himalayan mountains. And so they build this enormous landscape that is just incredible and incredibly dynamic, both in terms of the natural systems, how a river naturally moves and flows, and also how people who are now living on this landscape, how can they live on there sustainably over time.
This project is focused on understanding whether this landscape, the delta, is going to be sustainable through time, given predicted changes in sea level. The interesting part is that there's lots of scales in the system. You can look at the whole delta together, but you can also look at the actual human scale of the polder where people live.
The example that Bangladesh has to offer the rest of the world is a society that has developed in the context of environmental change and dynamics. Every year, 30 to 50% of the country is underwater for several weeks to several months during the summer monsoon. And so here we take farmland that's seasonally converted to open water, and it shifts from agriculture producing grains such as rice and wheat to aquaculture producing fish and shrimp. And so there's this duality of the environment here. And so the society here for thousands of years has been adapted to rapid environmental change, which is the risk that the rest of the world faces as we have changes in climate, rates of sea level rise, and growth in populations and changes in economy.
Being here and understanding how the network is organized and how water, sediment, and nutrients are transported to the system, how these people are going to be able to survive given current predictions of sea level rise. This is what we do in civil and environmental engineering.
One of the really cool things about this project is bringing so many different people who look at the world in different ways. They have different expertise, they have different ways of thinking about problems, and they look at different parts of the problems. And this project brings us all together so that it's not just about everybody doing their research. We're learning from each other, and when we go out in the field together, this is really cool because we get to watch each other do the work that we do. I get to watch how somebody who's a sedimentologist does his work. I get to watch how a social scientist does her work. And this lets us start to look through each other's eyes and start to make connections we'd never make if this was a bunch of separate projects that people were doing all on their own.
So on this project, I'm focused on maritime transportation and economic impact. So I want to understand how these environmental changes are impacting inland waterway navigation. The changes in river dynamics have resulted in kind of like a reconfiguration of the inland waterway channel network. Some channels are no longer navigable, whereas others have become, the traffic has significantly increased. So specifically we want to see how vulnerable some of these links and nodes on the inland waterway network have become as a result of these changes. if we can understand or this relationship between environmental changes and the socioeconomic impact, then we can actually project into the future and be better prepared for further changes in the environment.
So my role in this project is to look specifically at the elevation dynamics of the delta system here in Bangladesh. And in this particular region, we have some areas that there's a very large population that lives here in something that's called an embanked island called a polder. And over time, these elevations have essentially gone down because we put these polders in place, and they have obstructed the natural delivery of sediment. So I am comparing essentially the elevation dynamics within that polder versus an area that's immediately adjacent and natural. It's called the Sundarbans Natural Forest. And it's a forest preserve. It's got enormous ecological importance to this region. But that is also an area where the tides are naturally delivering sediment to these regions. So it's important for us to understand the elevation dynamics both within the natural system and understanding how that is keeping pace with sea level rise, that's both man-made and natural, versus what's happening in the areas where people are living, the human-modified areas where there's a lot of land use change going on. And then if we can have that information, we can make better informed decisions on things like coastal management and make some recommendations to maybe prevent loss of life and infrastructure.
One of the things that I've been focusing on with my students is studying the water because they have a lot of different problems. They're growing rice, for example, in these rice paddies, and a lot of the water in this area is salty and arsenic, bearing, and so the concern is that the rice yields will be decreased because of the salinity of the soil. And the rice can take up the arsenic and then lead to poisoning of people. Together, we're sort of looking at all of those and first seeing how much arsenic, for example, is in the soil, and then how much dissolves in the soil water, and then how much is taken up by rice or shrimp. What's surprising is that we have a very poor understanding of what is causing the salinization. And in fact, these tidal channels that we're on, over the last few decades, they have increased in salinity in the dry season, and we don't really know why. We have some hypotheses, but we haven't developed good tests yet to decide which one is accurate.
So my role in the project is to make measurements primarily within the tidal channels of the processes that are going on, how fast is the water moving, how much sediment is in the water, what's the salinity, those sorts of things, to understand not just the hydrodynamics or the sediment dynamics, but then to pass that information on to other people in the project. So if we want to understand how land is being built, we need to understand where the material is coming from, how much material there is, when is it coming to this region. So I'm working closely with the people making the measurements on land, but also these data are really important for the team members who are constructing the numerical models, who are looking at how the system behaves across timescales and spatial scales that I can't make direct measurements of.
I think as a modeler, we always tend to ask for data of other people, and in this project it's set up to do that much more intimately with partners of the different groups and with the Bangladeshi participants and the Bangladeshi partners. And so I think for us it creates a deeper understanding of the data that we use to constrain the models or to run the models and how predictive we can get.
Because we're trying to forecast change through a long time, then of course you rely on numerical models. So part of our work is in fact modeling in collaboration with the researchers, for example, at Colorado Boulder as part of this project. And so how do you go from a very complex network to inputting this information to a numerical model? We can't model it all. So what we're trying to use is network theory and statistics to understand what are the dominant characteristics of the network and what to embed in the model in such a way that it represents closely how the actual landscape looks like, and thus we can make forecasts and predictions on the future behavior of the delta that are reliable, that we can trust, and thus we can take management decisions based on that.
Right now, when we look at environmental problems around the world, this is almost all things that involve very technical aspects about how the environment works and also parts about how people work. And so you have to be able to make these connections so that the science is really going to be useful in informing people about how the environment's changing, how we can preserve our quality of life with these changes. And so bringing these interdisciplinary groups together to work together, learn together, and make sure that all the results of our research fit together is a really important part of making sure the results then are going to be useful for helping to protect people's quality of life.